Welcome everyone to the next lesson in this series, and in this video we will look at selective BGP peerings from nodes in a cluster to a top-of-rack switch or a router. Now, in some of the previous lessons we looked at how you can peer nodes in a cluster with a top-of-rack switch to advertise load balancer type services and pod IP pools. Now, in those lessons, we peered all the nodes in the cluster with the top of rack switch. But as your clusters scale to dozens, if not hundreds of nodes, especially in on-prem clusters, it's not practical or viable to maintain BGP peerings with all the nodes in the cluster. So in those instances, what you do is designate a few nodes in the cluster to peer with a top of rack switch and make those nodes responsible for steering inbound traffic towards the cluster. So in this lesson, we will look at how you configure such a topology. Let's get started. All right, let's look at the lab topology. In this case, we have a 5-node Kubernetes cluster, and we will be designating 2 of those nodes to peer with the top of rack switch. Now, if you look at the Calico configuration resources, the BGP configuration is the same as the previous lab. In this case, we are advertising the service load balancer IP range to the upstream network. If you look at the BGP peer configuration resource, there is a change this time around. We have a node selector with a label BGP peer equals true. And the idea behind this is you can label the nodes that you designate for the peering purpose. So in this lab, as an example, we have worker 1 and worker 2 with this label, and as such, Calico will initiate BGP peering sessions from these workers to the top of rack switch. And the IP pool configuration for the load balancer IPs is the same as the previous lab as well. Now, if you look at the Arista CEOS configuration, we are using BGP listen ranges, again, similar to the previous lab. And the reason I like listen ranges is because we can horizontally scale. So as your clusters scale, you can start off with 2 nodes, but then increase to 4, 8, 16 by simply adding a label to the node from which you want to initiate the BGP peering to the top of rack without making any configuration changes to the upstream network, right? So this is something you can negotiate with your networking team to have those listen ranges. If not, the peering sessions have to be individually configured. And in this lab, we will look at, once the topology is up and running, how the routing table is configured for equal cost multipath load balancing towards the 2 worker nodes with the BGP sessions. Okay. All right, let's go through the lab guide. I have gone ahead and deployed the lab in my environment. You can find the lab in folder number 15, selective BGP peerings. Once the lab has provisioned, you can export the kubeconfig file. And once done, you can issue commands like kubectl get nodes. As you can see, we have a 5-node Kubernetes cluster. Now, if you do a kubectl get nodes and show labels and grep for BGP-peer, we have 2 nodes in this case. Worker, which is essentially worker 1 and worker 2, configured with this particular label, and we will use this label as a selector to define the nodes that will peer with the upstream top of rack switch. Next, if you do a kubectl get BGP peers, we have a single peer definition. In this case, it's called BGP-Arista. We are using an Arista CEOS image as the upstream container image, and the peer IP is 10.10.10.1, and we are selecting these nodes with the BGP peer-true label to peer with that peer IP address. Next, we are going to apply a manifest for the LB IP pools. Before we apply this, let's do a cat, and this is what the manifest looks like. Relatively straightforward. We will be configuring a load balancer IPAM pool so that Calico can assign load balancer IPs as you define those services. So let's do a kubectl apply. And if you do a kubectl get IP pools next, we can see that the load balancer IP pool has now been configured. Next, we'll configure a load balancer type service for the Nginx workload. And if you cat the service definition, again, pretty straightforward. We have a type load balancer service. So once this is applied, Calico will go ahead and assign a load balancer IP to that service. If you do a kubectl get services, we can now see the LB Nginx service with an external IP of 172.16.0.240. So with that done, let me clear my screen. Next, we're going to apply the BGP configuration resource. So this resource will start advertising the service load balancer CIDR range to the upstream BGP peers. So let's go ahead and apply that. And once done, what you can do is exec into the top of rack switch or router, whatever you want to call it. I know I use those names interchangeably, but if I do a show IP BGP summary once I'm in the switch, we can see that it has two BGP neighbors established, 11 and 12, which is basically worker 1 and worker 2. And it has also received, prefixes from those BGP neighbors. If I do a show IP route, we can see that the LB IP range has a next hop of 10, 10, 10, 11, right? Now, the Arista router in this case is not going to be doing equal cost multipath load balancing, by default. For that, we will have to configure the maximum paths under the BGP configuration. So let me go ahead and do that. So inside the BGP settings, I can say maximum path 4 this time. And if I exit and do a show IP route again, we can now see two next hops for the LB IPAM CIDR range, right? Pointing towards worker 1 and worker 2. All right. So next, let's verify connectivity. So the IP address, as we saw previously for the LB service, was 172.16.0.240. I mean, this could differ in your lab. So first retrieve the IP address, and then you could do a telnet 172.16.0.240 in my case to port 80. And as you can see, we were able to successfully connect to that service from the upstream network. And what that means is now we have reachability to that service from the rest of the network. Okay. So let me do that one more time. If I do a get, we receive a response from the Nginx workload. Okay, so next let's look at how we can horizontally scale. So we had worker 1 and worker 2 paired with the upstream network. Let's go ahead and apply the same label to worker 3 as well. And once done, if I exec into the switch, do an enable and do a show IP BGP summary, now we can see 3 BGP peers. And if I do a show IP route, we can now see 3 next hops towards the LB IPAM CIDR range. And what this means is the top of rack switch can now send traffic to, or rather load balance traffic to 3 nodes for services configured in the cluster. All right. So the idea behind this is that as your clusters scale, and in on-prem environments, it could be dozens, if not hundreds of nodes, you can horizontally scale the number of nodes that advertise the LB IPAM CIDR range to the network so that traffic can be load balanced between these nodes as well. And this is a very important consideration. I've seen instances where clusters were impacted because the number of nodes bringing in inbound traffic was limited, and these nodes have a maximum session count as well. And if you've scheduled your ingress Nginx workloads or gateway API workloads in those nodes as well, which tends to be a very common pattern, those workloads also have a maximum number of sessions that they can handle. So you may want to scale them accordingly as well. Okay. All right, so that's it for this lesson. I hope you found it informative. Thanks for watching. I will see you in the next one. Bye.